You can pick whatever points you want. I'm going to choose for simplicity, and because I'm boring, I'm going to choose 0, y, and
1.
No.
0, y, and 1 works.
1. Oh, let's do 0. It's fine.
Oh,
Which is
then you
gonna
get a
be,
fraction.
That's fine. So we're going to have 0 minus 3y plus 0 equals 8. Y equals negative 8 over 3. So point B is going to be 0, negative 8 over 3, comma 0. Now, Michael was asking, can I please go here, please? Michael was asking a question. Why can I not change that to negative 8? One more time? Oh. That's better. Better now? Okay, why can I not multiply that by 3? That's a point, not a vector. Okay? So vectors you can change them as far as the length of them, but points you can't change the lengths of. Point C is going to be then x comma 0 comma 0, which is going to be 2x minus 0 plus 0 equals negative 8. So x is negative 4. So this point is going to be C, negative 4, comma 0, comma 0. And my A was 0, 0, negative 8. Okay, continuing on there, I'm going to say vector S. Okay, guys, please stop. Vector S is going to be AB. You could have chosen different vectors. So AB is going to be 0, 8 over 3, comma 8. I'm going to call S equal to 0, 8, and 24, which conveniently is 0, 1, and 3. Is that right? T is going to be BC, which is going to be negative 4, negative 8 over 3, comma 0, which is 12, comma 8, comma 0, which is 3, comma 2, comma 0. Now, I had a little conversation here with my friend Benny while he was working on this question. Okay, and he said, "Is this right? Is my answer right, Mr. Sadler?" And I said, "I don't know." Okay, Ben, can you explain in the class why I said I don't know?
Because I chose different points and an amount of points.
Yeah. Every point will make, unfortunately, the parametric and vector equation of the plane different. The scalar of the plane will always be consistent, which makes it nice, okay, but depending on what points you pick, because think, if you were to pick these your direction vectors, if you use the blackboard, this will work, okay, as a plane. I can pick this and these two vectors will work. I can pick this and these two vectors will work. They'll all still make the same point, okay, right? Versus the scalar, which won't be 1. So as far as my vector equation, it's going to be, I'm going to choose 0, 0, negative 8, plus S, 0, 1, 3, plus T, 3, 2, 0. X is equal to 3T. Y is equal to S plus 2T. And Z is equal to negative 8 plus 3S. All right, I'm going to write your homework on the board. I want to do one last example. I can squeeze through it, okay? Homework is going to be page 459. And Mike, I'd like you to remind me tomorrow if you would check homework for a change. I keep forgetting.
Tomorrow are we doing matrices?
Not yet. Getting closer though. Example, we're up to 4 or 5. 4? 4?
Except we don't use graphic calculators.
No, we don't. Okay, here we go. Find the distance. No. Maybe. Not today. Okay, here we go. Okay, so what we're going to do here, right now is we want to find some distances. Okay, we're going to assume right now that the point is not on the plane. We'll be checking that later on. If the distance was 0, it would actually be on the plane. So this is going to be that. All right. What's my normal going to be, please, for this? Oh goodness. what's the normal going to be for that plane? So what we're going to do is we're going to find the normal. And any point on the plane. So the point on the plane I'm going to choose is going to be 0, 0, and 41. It's going to be the point. Any can be used though. Okay, why is it 41? Okay, the question for whoever was for that was our equation was equal to negative 41, right? So it'd be 0, 0, and that. We're going to say that the perpendicular distance yeah. Where are we here? Oh, it's a Z, so I can't print properly.
You can change it to -4. Yeah.
Sorry, I can't. Is that good? No? Better? Never clear?
That's a
Okay,
weird
good.
looking thing.
We're going to say the perpendicular distance from a point is the shortest distance. Okay, now I'm just going to give you guys a second to scribble that down, and maybe I'll get some meter sticks. I may not be able to rush through this example because this is sort of a big concept that I'm going to do here. Michael, can I use you as a helper? Okay, this whiteboard is going to be my plane, which is lovely. Michael is going to be a point. Michael, can you hold your hand out? That's going to be a point. Okay, great. So this is going to be the point. I want to find the distance from the point to the plane. What's the shortest distance going to be? Straight across, that's a perpendicular one. Okay. So here's the thing. What I did for my left-hand board, I picked any point on the plane, which I'm going to be closer so I can hopefully find it here. Okay, good. So we have a normal, which is going to be coming out this way, and we have a point on the plane. How do I find? That's good. Okay, from there to there. How do I find this compared to the normal? What would I do to relate this to the normal? Triangle, good. But how would I find? How do I find this? How would I find this? How do I find that? It is like that, good. I want to use something involving the calculus. Cross product, close. Sorry? Projection, that's what I use here. So you put your hand down there. So what we're going to do here, hold on a sec. So what we're going to do is we're going to project, can I talk it please? We're going to project the line from the point to Michael's hand, so the point on the board to Michael's hand. We're going to project that onto the normal, and then we're going to find the distance of that, and that's going to be your minimum distance. Okay? So we're going to find the distance between the point and any point on the plane, project it onto the normal, and then find that distance. Let me write that in the book, Michael, for your assistance.
So that would be the magnitude of the depth.
Yes. So what we're going to do is we're going to use I'm going to call this X. Project the X on the X. I guess AX is technically a vector then. Okay. So, let's first of all find AX. What's AX going to be?
So 0, 0, 40.
Is that okay when I say that? Is it really too quickly? Is that okay with where that came from? Yep. Agree with it? Okay. All right, so now we're going to do the projection.
It would be 42.
Sure.
And just -1. So subtract
Not
negative.
here, so not here though. We're using this, so yeah.
Oh, we're using point A.
Yeah.
Oh, okay.
Okay, so we're doing the projection. Projection of AX onto N. Now, not everyone apparently knows this looking at your tests. So I project AX onto N. Can someone be brave with a great deal of self-confidence and give me the equation, please? Go ahead. Yeah. Sure about that? Yeah. Okay. What's going to happen for this, though, we're just going to use this definition. Those are going to cancel. So we're going to say the magnitude of AX dot N, whoops, all over magnitude N. That's what we're going to use for this. Okay, so here we go. Can someone remind me how we dot things? Someone follow we dot things. Go ahead. Good. So just as a reminder, your N hat here should have been 4, -8, -1, is that right? So this turns into magnitude of -3 times 4 plus 1 times 8 plus 40 times -1. Thank you. All right, how do you get the magnitude of N, please? N magnitude of N hat. Yeah, go ahead. So this turns into the magnitude of -12 minus 8 minus 41 all over the square root of 16 plus 64 plus 1, which equals the magnitude of -61 all over root 81.
40 times -1 is 40.
Oh, goodness gracious me. Good thing you guys are here. I could have been in real trouble here. Equals 60 over 9, which is 20 over 3. Which makes the question look a lot nicer. Now, if you care, which you probably don't, okay, I chose a different point on my example here, so I'm saying X, which is good. So the neat thing is you can pick any point on the plane. If you want one question to put a star and a heart beside, it's going to be example of this one. Okay, if you want a second question to put a star and a heart beside, it should be the previous two when you're converting from different types of planes. But I like this question, hint, hint, nudge, nudge, wink, wink. And we're going to be using this a lot in the next few days there too. Yes? Yes. So the magnitude of projection, that's what it was. Okay. We'll be using this sort of stuff quite a lot in the next few days. It still would have worked within the magnitude of all that. Yeah, it would have. Yeah. Not that bad. I can read logic with. I think we're done. We're done. Come on, lighten up. Come on, not that much. Can't crack one joke. Yay Math is going to be watching this one day. What's he going to think of me? My lame jokes.